And then we'll do quadratic formula, review that a little bit. Okay, so if I do ask you, right, how many are possible, you know that you're going to have to justify, right? So we look at, there are two sides, and we know that there's a pair here, right? So this is an SSA for sure. And specifically an acute, we have an acute SSA case because it's less than 90. So then your triangle, or your fishing rod and string, I should say, this being X here, this is 13 degrees. This would be 12, oops, sorry, 12. We don't know the units, so you would just add the units, okay? And the other side, automatically we put it there. Okay, so this is the string, this is the rod, okay? So first thing you want to look at is compare these two, right? String is less than rod, therefore I need to find the height, right? And the height is always this slanted, right? The side that's touching the angle in question, right? Or the angle provided, I should say. So it'll be 15 times sine of 13. I don't know where my key is for this one because it's an old AC that we didn't use yet. 6.30, right? Rounded. And we would just add the units to that. And here you just compare the string. It's always the string and the rod first of all, and then it's string and height, right? The string and height, you say something about them and just look at the numbers, right? The string is actually greater than the height in this case. Therefore, two solutions. And just a note, if the string had been less than the height, no solution, right? If the string is exactly equal to the height, one solution. And it's actually a right triangle. Right? If these two numbers are exactly the same, if this swings in, it's going to touch just once right here along the height. Right? So then you have your one solution. So just keep that in mind. Also, let's go back. If this had been, if you notice that this is longer than that, case closed, right? It's automatically just one triangle. So keep that in mind. Same thing, M&M, SSA. This is an obtuse case. I think this is it. I'm just going to do one more. So here we have that scenario, something like that. This is 170. This is angle M. And the side across from it obviously is over here. And this is 11. And you never find the height here, right? No need to find the height. No need to find height. Sorry. Find height. All you do is you compare the string and the rod, right? In this case, the string is greater than the rod, therefore one triangle. One triangle, one solution, the same thing. So just like it shouldn't take you long. However, I do give 2 or 3 marks for these types of questions, right? So you will actually see that the exam marks overall add up to a lot, but it's because a lot of them, if you know what you're doing, they're quick, right? This shouldn't take you longer. Something like this shouldn't take you longer than 2 minutes, to be honest, right? 2 minutes and then move on, okay? That's it. Watch out for, is there one that wasn't SSA? This is SSA. They're all SSA. So let's say here, triangle big, right? If this would have been I instead of B, right? If you see two sides, but you don't have the angle crossed, it's not the SSA, it's automatically one solution, right? No need to justify, you just say it's not SSA, one solution, right? If that ever comes your way, you know that, right? That's it. Hopefully you had fun with it. And put this away. Yeah, so this one has this one I actually made for exam review. So it has some quadratic formula. It has a little bit of triangle. I think we're gonna leave the triangle today. I think trig we have that under control. I think. Okay, let's leave trig. Just do the quadratic formula, and then ready for this? Dun, 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 right? Just graphing a non-contextual inequality. So quadratic function, and then this, and just thinking. Just this, yeah, just this question. So the first one and the third one. That's all I'm going to ask you to do, and then I'll do. I think time will be okay to do one inequality that involves a word problem. Inequalities with word problems. Just that one last thing, and then obviously after you did the inequalities first, and then you came back to this. That's fine. So remember your quadratic formula. Make sure you have that right. Okay. I don't know what version you have. Understanding that this line right here, oops, I don't have that. This line right here goes across the whole thing, right? So you divide this by, is it 2a? Okay, whew. 2a. Okay. So that's the one. So basically the reason I put brackets is because, right, this could be a negative, this could be a negative, right? You plug it into that. Anyway, so let's distribute this. So that's 3x squared minus 6x is equal to negative 4x squared plus 7. Okay, that should be your first step, distributing that. Then bring everything over to the left, right? So it's 3x squared. This 4x comes over adding. The negative 6x is already there. Then the 7 comes over subtracting like that, and that equals to 0. That's what you want to do, right? And then combine your like terms. That's 7x squared minus 6x minus 7 is equal to 0. Perfect. A is equal to 7, B is equal to negative 6, C is equal to negative 7. So try to be as fluent as possible here, okay? And then we plug in negative B. See how that works? The bracket, you plug in whatever B ends up being. Too many B's in that statement. And then you go like this, and it's negative 6 squared, which will always be a positive, minus 4 times A times C. Okay, that's how you enter that. And then it's equal over 2 times A. And I'm going to run out of room, but I'm going to borrow from the next question there. Or maybe I can make it work. So clean this up. Negative and negative is 6, plus or minus. Let's figure out, we know that the bottom is going to be 14, right? 2 times 7. Let's figure out this part. So follow me with your calculator perhaps. So I'm going to go negative 6 squared like that. You can't go wrong if you use brackets, right? Minus 4 times 7 times negative 7, right? That will take care of everything if you use brackets, and that's 232. So you clean up whatever's inside the root. This turns out to be this, and then you branch off, right? The one root will be 6 plus root of 232 over 14. And the other root will be x is equal to 6 minus root 232 over 14. Now, remember that if this discriminant is negative, no root, but you got to tell me why you stopped. If this is 0, then it's only one root, right? It's only one x-intercept. So this would be, let me just cheat a little bit. I'm going to look at my key here. You just have to make sure you enter it properly. So this one is 1.52, and this one is negative 0.66. All right. I'm okay just leaving it like that at this point. But you just got to understand these are x-intercepts, which are our solutions, which are our roots. Right? So that's all the same. I'm just going to double check because this one looks a little fishy here. 6 minus root of 232. I hit enter. Then I divide by 14. We're good. Right? So you got to make sure after you do the numerator, hit enter, and then divide by 14. Don't do it in one shot because it's not gonna work. Watch. If you do this, you get a totally different answer, right? Because it's only dividing this here, dead mass, right? Division before addition and subtraction. So don't make that silly mistake when you're that close to the finish line, right? Okay? Don't be scared. Just be confident, right? You'd be surprised you can still earn partial marks even if you make a mistake along the way. Backside, because of our time, I kind of took the liberty to get it started already. So let's just see what this works out to be. I give you full permission to just put a little 1 on this one and then just you don't have to rewrite the whole thing, right? So I found my x and my y-intercepts. That gave me that and that. Then I had to rewrite it. So I take this down here, and you should have noticed, right? First of all, I bring the 3x over to the other side, negative. Then I have to divide by -1, right, to get rid of that, which flips the sign. That's important. And this negative affects both of these terms on the other side, right? Turning the 3x positive, the 5 negative, right? Solid, the true region is above the line, and I'm going to shade below. So this is very important to me. This is what I'm going to use for shading. Then I found the intercepts for the second inequality here. -6, 0, 0, -3. I'm going to rewrite this for y is greater than -2x, right? Because the 2x comes over -12. Okay. Divided by 4, divided by 4. Nothing flips, right? This is just -1/2 x minus 3, which, right, this should jive, right? Your y-intercepts. Box that in, because I'm going to enter that later. This is a dashed line. True should be the same as this one, right? True is above. I'm going to shade below. Right, so that's what I'm going to use for shading. And then this one, you know it's only one variable. It's actually a horizontal line. So it's just 3 minus 2, right? The 2 comes over. Don't introduce an x in there, right? A lot of students want that x to appear. Don't do it, right? It's just keep it like that. Okay, so in this case, it's a dashed line. True region is below. We shade above, very important. I'm going to use that to help me out. Then we're ready to go. Somebody took my ruler earlier from the other class. Oh, I got it back. So here, let's do this quick. So y1, positive 1 right there, and it's dashed. I'm not going to be too picky on the labeling right now, but that's one line. And then this one, 1.67 is right about here. 0, -5 is right there, and it's solid. Okay, right there. And then I have -6, 0, 0, -3, and that one is a dashed, right? If you got this wrong, see it this way, you got to practice it one more time, right? So obviously labels would be everywhere. Shading. So this line here I shade below. It's not going to be the prettiest graph, okay? This other one here, I shade below as well. This one I shade above. So this is my solution region right here. Okay. What else do we need? Corner points. These corner points here. I think I'm just going to give them to you. But in this case, you can enter everything into your calculator and just find the intersections. So here they are. One of them is this one right here is 0.57, negative 3.29. By the way, I'm posting this key as well. I already did actually. This one right here is 2.1. And this one up here is negative 8.1. And this makes sense, right? That we have 2 ones there because it's this horizontal line that meets it, right? And that's that. Okay. So this is a non-contextual. So you use the whole grid, and I will provide you with grids everywhere. Wherever there's a graph, there'll be a grid. Okay. So you can be guaranteed a grid. Just bring a ruler. I should have mentioned that already earlier. Bring a ruler. Make sure you bring a ruler. I'll post. I'll make an announcement. Maybe even the day of. I'll have a few extras, but not for the whole class. Okay. All right. So that's that. I think I'm going to pause here before I give you the other one and just quickly talk about